Well, hello, good morning, good afternoon, good evening, depending on where you are. My name is Samantha. I'm from Safeopedia, and I want to welcome you back to another one of our webinars. At Safeopedia, it is our mission to help you, our EHS professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I want to extend a huge thank you to all of you, our dedicated safety professionals, for the great work you do on a daily basis in keeping our workplaces safe. Today, we are proud to present Rethinking Safety Metrics, why PSIFs are the new standard for evaluating workplace risks. The webinar has been made possible today by Velocity EH&S. It is now my pleasure to introduce today's presenter, Greg Duncan. Today, Greg is going to discuss how software technologies, including AI and machine learning, can support PSIF tracking, analysis, and insights. I'm very excited to have you all sit back, relax, and enjoy this presentation. With that, Greg, let's jump into it.
All right, thank you, Samantha, and thank you everybody for joining us today. Yeah, let's dive right in. First of all, let me introduce myself a little bit. My name is Greg Duncan. I'm a Master of Environmental Law and Policy. I'm also a BCSP certified safety professional, and I am Senior EHS and Sustainability Content Manager at Velocity EHS. I've worked with Velocity EHS for about 10 years, working on our marketing team, developing educational content for folks just like yourselves to help you, better your workplace health and safety programs and to, improve safety outcomes. Prior to joining Velocity HS, I worked for about 7 years with the National Marine Fisheries Service and the Alaska Department of Fish and Game as an onboard compliance monitor in the commercial fishing industry, where I lived, and worked aboard commercial fishing vessels in the Bering Sea and in the or I should say, the Northern Pacific, helping to monitor natural resource compliance with natural resources regulations, as well as occupational health and safety standards. Um, so yeah, there's a little bit about me. If you see this picture behind me, you'll notice this mountain here. That's Kiska Island. This is out at the very, very end of the Aleutian Islands chain. So you can Google Maps that. All right. So first things first, as always, we're going to go through our session agenda. We're going to start off by talking about SIFs and PSIFs, our potential for serious injuries and fatalities, what they are, and why they're important. And then that's going to transition nicely into a discussion about how we measure injuries and illnesses and what kinds of metrics we're using, both lagging and leading indicators, in order to track injury and illness rates, and in order to help us target our health and safety improvement efforts. And then lastly, we're going to talk about how AI can support that and how the technologies that are emerging today, some of them, that are part of the Velocity EHS software, can help to, provide some more robust and detailed insights regarding your health and safety metrics to help you pinpoint where your efforts are going to make the biggest impact. And then finally, we'll have a Q&A. So I definitely encourage everybody today, if you have any questions about anything at any time, go ahead and put those into the questions box in the Zoom window, and we'll have a brief Q&A at the end. All right, so some of you have probably heard about SIFs and PSIFs, but we're going to go through kind of some basic information about what they are and why they're important in terms of, monitoring injury and illness rates and being able to track safety performance. So at a basic level, what are serious injuries and fatalities, or SIFs? There's a lot of definitions out there. There are, a lot of different companies, organizations, insurance carriers, and regulatory agencies, industry associations define them a little bit differently, unfortunately. These are just a snippet of some things from the Professional Safety Journal. That's the magazine publication of the American Society of Safety Professionals. This is from back in 2023, so a couple of years old. And they surveyed their readers and found a number of different responses when they asked, how do you define SIFs? And, you can see here on the left, there's a variety of different explanations. And that ultimately results in some differences in how we're defining these and how we interpret or how we perceive the risk of serious injuries and fatalities or SIFs. The problem with that is that when it comes to comparing individual companies' performance um, from one organization to the next and across industries, we don't have a great standardized definition to be able to compare things apples to apples. And so what we need to do is, create a standardized way of defining what a SIF is in order to be able to measure them and then ultimately be able to, obtain any sort of insights about them. Even within an organization, if we don't have that consistent definition, our ability to track them from month to month, year to year, is going to have a certain amount of variability in it because different people might define them differently, and you've got these inherent differences in perceptions of risk and what SIF risks are, and so just the inconsistencies relate to or contribute to a lack of inability to track them over time. So what we need is to define them consistently, and that's where the life model comes in. This is proposed by the same researchers at ASSP. They propose this life model as that standardized definition. So anything that meets these criteria, these three criteria, would be considered a SIF. So if it is a life-ending injury, if it is a work-related fatality, that would definitely be considered a SIF. If it is life-threatening, meaning that it requires immediate medical intervention, sorry, or life-saving support. So, we're definitely not talking about just first aid here, and we're definitely not just talking about, minor medical consultation. And I never realized that's kind of a subjective term there. But basically, if you have to call the ambulance, if you need immediate hospitalization for a work-related injury or illness, that would be considered life-threatening. And then lastly, life-altering. If the injury results in a permanent disability or other impairment or loss of ability, loss of body function, that would be considered life-altering. Um, and if it is not any of these, if it doesn't meet these three criteria, then we would consider that a non-SIF. And so it's a relatively narrow set of criteria. I just want you to keep this in mind and kind of wrap your head around these definitions here, because this is important to keep in mind when you move forward and, God forbid you experiencing any types of injuries like this in the workplace. But if you do, that would be the kind of injuries or illnesses that fall within the SIF category. Why should we focus on SIFs? Why do we, distinguish them from any other types of work-related injuries or illnesses? Obviously, because these are often disastrous for businesses and workers, life-altering, life-threatening. They can have significant impacts to the business, to from a dollars and cents perspective, the costs of workers' compensation loss, productivity, insurance premiums, the list goes on and on. And so, we really want to make sure that we zero in on SIFs and SIF risks in order to save ourselves and save our workers from these severe life-changing consequences. But it's also because from a health and safety sort of operational perspective, the traditional injury and illness metrics that we use, things like total recordable incident rate or days away restricted or transferred, TRIR and DART rates, lost time injury rates, LTIR, whatever sort of metrics you're using, these don't tell a very complete story. They don't really tell much of a story at all when it comes to the sort of level of severity of these injuries. The spectrum of severity these injuries could be. They're really just telling us how often an incident is happening, and that's pretty limited when it comes to being able to um, really focus our efforts where it's going to have the biggest impact. Obviously, SIFs are associated with high hazards, things like uncontrolled release of energy, um, machine safeguards, other high hazard high hazards or extreme hazards that are present in the workplace that we should really be focusing on. It sounds obvious, but there's a very direct correlation between SIFs and the presence of these extreme hazards in the workplace. And so when we're able to zero in on SIFs, we are therefore able to zero in on those high hazards, target them, and address them with the appropriate controls. The other thing is that, you know, with a increasing number of contractors and temporary workers entering the workplace, if we're depending on these, more traditional frequency-focused safety metrics like TRIR and DART rates, in order to indicate whether a contractor or temporary worker meets our requirements for being able to enter the workplace. Do they meet our safety standards that we're going to bring them in and have them do work for us? It doesn't paint a full picture of that contractor, temporary worker, temporary employer's safety performance. And so we need a better way to be able to assess whether or not that temporary worker or contractor is, presenting some sort of a risk that they're bringing into our workplaces when they come through the door. And, lastly, just kind of rounding it out, if you have a low injury rate on paper, it can give us this false sense of security. Maybe we have a low injury rate, but those very few injuries that occur, they could be very severe, and the costs of which are commensurate with that severity. And so, even if we've got low injury rates, we could still be presenting a very high risk, high severity, and probability coming into our workplaces or in our workplaces. And so this is kind of backed up by a lot of data that's out there. I'm going to show you some charts on the next few slides. Basically, what we're looking at is the distinction between non-fatal injuries and fatal injuries. And you see on this chart, this is from the U.S. Bureau of Labor Statistics over a period of almost 35 years, looking at total recordable cases or total recordable injuries, and also workplace fatalities. So employers, health and safety professionals are doing a great job of bringing that rate down. I mean, you look at just the last 30 years, that rate has been cut by more than 100%. Like it's gone from around 9 down to below 4. But at the same time, we're seeing workplace fatalities staying essentially constant, unchanged for the most part, over that same period of time. So what's going on here? If we're doing such a great job at preventing these minor workplace injuries or non-fatal workplace injuries, why aren't we making a similar reduction in workplace fatalities? We zoom in a little bit on that same trend here. This is actually looking at the rates, or that previous graph was looking at total numbers, but it's essentially the same trend. And we've gotten workplace non-fatal recordable injuries below the rate of fatalities. Like this is actually, we've had this crossover point here, and we are now better at reducing non-fatal injuries than we are at reducing fatal injuries. Again, why? What is happening? What is this phenomenon that we're seeing here where we're not making a dent in workplace fatalities? Similar trends seen in Canada. It's not just the United States. And I had done this presentation a while back and looked at some data from um, uh, Australia, from their workplace health and safety agency, their data, and we're seeing the same trends. We've got some very, very substantial reductions in certain provinces and territories at reducing these non-fatal, these are lost time injury rates. So non-fatal injury rates. We're making good progress at reducing those, but we see on this chart here, these are in the red, occupational disease fatality rates, and then in the blue, injury fatality rates. So both lines indicating work-related fatalities. Um, we're seeing those work-related injury fatality rates staying essentially the same. If we look at Quebec and Ontario, they have much larger populations in those provinces, so larger sample sizes, more employers are reporting here. Um, but we're seeing that same trend, flatline on workplace fatalities, and even an increase in work-related occupational disease fatalities in some areas. And so, what again, I ask it again, what's happening here? Why are we better at reducing overall, non-fatal injuries, but we're seeing a steady or even increased rate of work-related fatalities? I don't have the answer at the moment, but um, it's possible that we're not looking at the right types of injuries and illnesses, or right types of incidents, or the right types of hazards. Maybe we're overlooking these severe hazards that are contributing to these fatalities and occupational disease fatalities. Um, Food for thought. Um, Another reason we might be missing SIFs here is because we're kind of taking the wrong perspective on how we approach um, the reductions and the controls of work-related injuries, and work-related incidents, just incidents overall. This might look familiar. This is Heinrich's safety triangle. It was developed back in 1931, I believe, around about that time. And Heinrich, famous, in the spheres of workplace health and safety research and the academic uh, arm of our industry. He did a large study. I think he looked at more than 75,000 um, injury and illness records at the time and found that he was seeing, for every 600 injury-free incidents that were documented, you're getting 30, I would say, minor incidents. Minor meaning they didn't involve lost time from work. And then within that same range or within that same sample size, you're getting 10 lost time incidents. And for every 600 injury-free incidents, these workplaces were experiencing one work-related fatality. This ratio has kind of guided a lot of the school of thought within occupational health and safety management over the past 100 years almost. And it has served us well, but it is time to move beyond this. This is almost, like I said, 100-year-old sort of way of thinking around how we manage workplace incidents and injuries and illnesses. Um, the thing is, though, is that SIFs, serious injuries and fatalities, don't really follow this sort of ratio, this prescribed ratio that Heinrich came up with. Um, some recent studies have found that only maybe 20% of these lower severity incidents have the potential for serious injury or fatality. And the conditions that contribute to SIFs are different than those that contribute to those, injury-free incidents or those minor workplace injuries and illnesses. So they don't obey this ratio. Um, and so by targeting them and by using this ratio to kind of guide uh, our perceptions around, how many types of incidents we're going to experience and what severity, they really break this mold. So we need to start thinking a little bit differently. Um, and this is just kind of reiterating what I just mentioned, is that, SIFs are occurring at a different rate than that prescribed ratio before. Um, and they're often hidden within these minor incidents where, something minor happened, but because of the conditions and the hazards that were present uh, within that injury or within that incident, they could have been much, much worse. So we need to make sure that we're, really investigating every incident to determine whether or not there were or was the potential for a serious injury or fatality or PSIF present within that. Maybe, let's say a worker is using a torch near uh, near a flammable, a tank that contains flammable gases. And there was some incident with that torch. Maybe there was the tanks fell over, or there was some other incident. Well, that could have made contact with this larger container, larger tank containing flammable gases, and then it could have resulted in an explosion, right? So, the presence of those conditions were there, but it didn't result in that serious injury or fatality. We need to recognize when that happens and not just, overlook it and thank our lucky stars, but we need to understand that there was a potential, there was a probability that existed for that to become a SIF. And that's the kind of scenario that we would term a PSIF. And that's the kind of thing we need to focus on preventing. Okay, long story short, um, PSIFs is kind of a larger umbrella term for a study of multiple metrics that we're going to talk about here in the next few slides. Um, Things that we should be looking at in order to determine whether or not there was a potential for a serious injury or fatality. So we talked a little bit about traditional lagging style injury rate metrics, things like TRIR, DART rates. There's some other ones out there. And again, these are really focused heavily on just injury or incident frequency. And they tell us very little about the severity of those incidents, let alone the hazards or the severity of the hazards that were associated with that incident. The severity of the hazard may not have been fully recognized or fully contributed to that incident, but we need to appreciate the fact that it could have. So if you're still relying, or yes, if you're relying really heavily on these lagging types of metrics, we're not getting the whole story. There was some research from the RAND Corporation that looked specifically at individual states' workers' compensation claims and injury and illness rates, and found that there was not a correlation between these lower non-fatal injury rates and the severity of those injuries. So basically, you could have that lower injury and illness rate, but you could have more severe injuries, as a proportion of that total rate. So, we need lagging indicators. Well, we have to have them for our injury and illness reporting. They're a big part of calculating our EMR when we're talking about workers' compensation claims. And we need these in order to be able to tell the full story of our health and safety performance, our injury and illness records. Um, but lagging incidents are only half of that. And we'll talk more about leading indicators in a few moments. Um, but TRIR is a good example of this. It's traditionally relied on by almost every employer to be able to identify the rate of injuries and illnesses occurring in their workplace. And this should look familiar. This equation should look pretty familiar to folks. This is how it's calculated across the board in every workplace. Um, and so it's calculated by documenting the number of incidents times 200,000, which is, it's just a constant. It's sort of a factor that's used to account for the number of hours worked over the course of a year. And then you're dividing that by the number of worker hours for your specific workplace. Now, as we're going to see on the next few slides, you know, this number is so widely relied on, but there are some major problems when it comes to um, it's actually like having it be a statistical representation of the injury rate and that sort of level of associated risk, or the implied level of risk within an individual workplace within a given period of time. I was having a great conversation with my dad over Thanksgiving dinner. He has worked in construction management his entire career, been part of multi-million dollar jobs, commercial contracts, high-rise buildings, doing, plumbing engineering, plumbing, heating, mechanical engineering for major facilities throughout Northern Illinois. And he was also the safety guy at his company. And he's been dealing with this calculation his whole life. And I was telling him about how I was going to, do this webinar. And we got to talking about how TRIR is really not a great representation of overall health and safety performance of true injury and illness risks, but it is unfortunately the key factor when calculating, or one of the key factors when calculating your EMR, your experience modifier for your workers' compensation insurance premiums, in that um, smaller companies, we'll see on the next couple slides, smaller companies are at an incredible disadvantage when it comes to calculating this rate because for companies that have fewer employees and fewer numbers of hours worked, um, the effect on how you calculate this rate puts those companies at a big disadvantage, and that when those smaller companies do experience an injury or illness, it has an outsized impact on their rate. So, for example, there was a study that was done. You can see the citation here back in 2020. It looked at some of the statistical implications of TRIR. And, basically what this slide is showing is that in order to be able to calculate your TRIR to within 500ths, so that's basically up to 2 decimal places, um, with statistical confidence or with statistical reliability in the calculation, you need to have more than 307 million hours of employee hours worked within the year, within the time period that you're calculating that rate. If you are working, or if you have fewer than this number of hours, um, that you're using to calculate your rate, you really shouldn't be reporting your TRIR rate to any more than 1 decimal place. And it sometimes, when you get below below 62 million hours, you really can't say with any statistical significance or confidence within 2/10 of that rate. So and we'll see this effect on the next slide. We do this calculation with a couple of different companies here. Company A, let's say they have a recordable incident recorded within the first 1,000 hours that they're in business. If you use the calculation the standard way, you'll calculate a TRIR of 200. And if you employ a statistical confidence interval within that, you're getting an extreme amount of variability. Somewhere your rate will be calculated somewhere between 35 and 1,125. Now, if you go to company B, they've got much more employers hours worked over the year, 980,000. If you calculate 7 recordable incidents with that 980,000 hours worked, you're then able to calculate TRIR using the standard calculation about 1.4. And then if you employ the confidence interval, you get a range, and that'll be somewhere between 0.69 and 2.95. Still, an incredible amount of variability that can have a real impact when it comes to calculating that EMR for your workers' comp premium rates. And then, on the other end of the spectrum, we've got company C. They have maybe 24 incidents, so much more than company B. And, company A only had one injury and illness within that 1,000 hours. Company C has 24 over 6 million hours worked. And if they calculate that rate, they've got zero point 0.8. And so you can start to see how just based on the number of hours worked, we're really getting a huge variability in our TRIR rates, and that it is, clearly not representative of reality. The calculation, the formula that is used itself is not statistically reliable. And, take that with a grain of salt because TRIR is still a chief concern when it comes to those workers' compensation premium rates, calculating your EMR. If a contractor, a company that's contracting you is looking at your TRIR rates and they're using these numbers, they're getting a pretty misrepresentative statistic to be able to say this company meets our safety standards or they don't. So that's why we need to also look at leading incident metrics to be able to paint a more full picture of our overall health and safety performance. So I'm sure all of you have heard of leading incident metrics before. There are, a universe of leading metrics that you can use to help measure overall safety performance. But, you know, at a very basic level, these are, not measuring past events. They're looking at the behaviors and the activities that you're doing as part of your safety program to contribute to a prevention strategy or to help you be able to predict, control, and prevent injury and illness risks. So these are things like uh, activity metrics around verifying that critical controls are in place. How many corrective actions are we opening, closing, and what is the sort of time to closure for those corrective actions? We're also looking at engagement metrics. This is really, heavily behavioral based metric. Are our leadership and our workers participating in the health and safety program? Are they participating in risk reduction and control activities? And then, of course, SIFs, reporting, learning on SIF risks, addressing SIF risks is a really great example of a leading indicator. So, there's a little bit of a gray area when it comes to defining between leading and lagging indicators. We don't want to get so caught up in the definitions and labeling them leading and lagging. We really want to focus on what are we doing with these metrics? Are we using them to report on past events, or are we using them to evaluate current and future behaviors that could be a predictor of future safety outcomes or future events? One example is near miss or near hit reporting. These are, of course, things that have happened. The near miss happened, but if we're using it as a way to learn and then act on the hazards that were present through that near miss, near hit, if we're using them to, make a proactive, proactive behavior or proactive action, then that would be considered a leading indicator. Even our number of recordable incidents can be considered a leading indicator if you're using them to identify and correct hazards that will impact future safety performance. And that's a really great example of how SIFs are tracking and then acting on SIF risks is would be considered a leading indicator. The point I just want to get across here is that a good leading indicator is not just measuring activities or what we're doing. It's telling us, giving us confidence that risks are actually being controlled. So when it comes to SIFs, how are we supposed to use them? How are we supposed to actually track SIF risks and then, engage in PSIF risk reduction? It all kind of starts with looking at past data, injury and illness data, incident reports, near misses, near hits, um, and going through every one, and ideally having a really strong uh, incident investigation report to be able to base this on, looking at everything that's in those reports to be able to identify the hazards that were associated with that. And thinking back to what I was mentioning earlier is that, even if an incident was minor, there may have been severe hazards that were present or associated with that incident. They just didn't contribute to or exacerbate the severity of that incident, but they were there. Recognizing that they were there is kind of the key to being able to track SIF risks. Um, when we look at the hazards from all of our injury and illness records, near miss data, um, we can then assess the severity of those hazards and determine whether or not they presented a SIF risk or had, a potential for severe injury or fatality. And then once we know that these hazards are present, we've sort of assessed them for severity and probability. So basically, we're doing a risk assessment. Then we can rank and prioritize them for root cause analysis. The root cause analysis allows us to identify, the underlying reasons and conditions that contributed to the presence of those hazards. And then from there, we assign one or more corrective actions or controls to address each and every one of those root causes. Now, selecting the right controls or implementing the right corrective actions is it's largely based on, or it should largely be based on historical or known control factors, risk reduction factors, as well as our own best professional judgment as EHS professionals in determining what the most appropriate control is for those. But the point is that we've identified all these hazards, we've been able to prioritize them based on severity and probability, and then we can actually go after them. We can get to work addressing them and controlling them with the most appropriate controls. Um, and part of that is making sure that we're communicating what we're doing throughout to operators, to people in that department, to health and safety leaders, to upper level management, making sure that everybody is kind of in the loop on what we're doing so that they know what's been changed, they know what improvements are being made. It's a big part of ensuring that these controls are successful in the future is making sure that the people who are affected by them know that they're there, they know how to operate them, and they know that they are making an impact at reducing the risk. And then, of course, doing a follow-up. However much time down the road, it could be, a day later, it could be 6 months later. Whatever the most appropriate interval is, making sure that we're following up to ensure that those controls have effectively reduced the SIF risk to the level that we've anticipated or a better or above and beyond that in order to track that we are addressing those SIF risks. And that is what, PSIF risk reduction and detection and risk reduction is all about. And this has been recognized. It's kind of becoming a more and more common topic among, thought leaders in the field of health and safety management. There's a new standard that's in development by ASTM, American Society of, I believe it's technical. Don't quote me on that. But it's ASTM standard E2920. They're developing it currently, and that is designed to provide this exact sort of strategy that we're talking about today for managing SIF risks and for developing a program to identify them, track them, control them. And many leading organizations are already on this train, developing PSIF detection and risk reduction programs within their health and safety management programs as sort of a subset of injury and illness tracking and prevention, designed to really zero in on SIF risks in order to, provide a little bit higher resolution around their injury and illness, overall injury and illness tracking. Because, as we've seen, there's a lot of sort of shortcomings of just focusing on total recordable incident rates or DART rates and these other lagging indicators that, don't tell us the full picture when it comes to injury and illness risks. Um, and that's sort of the bottom line here is, broadening our scope, getting a little bit more granular with how we're tracking injury and illness risks throughout the workplace and having good, solid, reliable numbers to be able to back that up, because that's ultimately going to help us drive better decisions around workplace health and safety improvements. And, that data is going to be valuable when it comes time to, obviously not only improve workplace health and safety, but be able to demonstrate that we're making these strides and these improvements and these steps forward to our workers, to our insurance carriers, to upper level management. And it's just going to improve decision making across the board around safety. Okay, so we've talked a lot about it. The thing that I wanted to, get across in that last section is uh, we often have to look backwards at past injury and illness records and near miss data in order to identify where these SIF risks exist in within our workplaces. Obviously we should be doing it with every injury or illness or incident that occurs, every near miss that occurs. We should be doing this on an individual basis, but um, uh, we're very likely going to need to look back at historical data in order to identify these risks and the trends in these risks over the long term. And that's a lot. That's a lot for an individual or even a team of individuals to do, is to sort through all this data. A lot of it is qualitative data. So we're not talking about straight numbers here. We're talking about semi-quantitative risk assessments, qualitative scoring of risk severity and probability. And how do we make sense of all that? Well, AI is becoming a great tool to be able to help us sift through all that data, identify trends and patterns in order to spot those SIF risks where, it would take an individual without it a lot of time and, probably more computing power than you could muster from an Excel file in order to find all this information and give us any meaningful insights. So AI, as you probably are aware, is kind of permeating every aspect of business. And it's steadily making its way into the health and safety realm, or the discipline of health and safety. And there's a lot of confusion. There's a lot of misinformation. There's a lot of apprehension out there around using AI for something as critical as workplace health and safety. It's a matter of life and death. So we want to kind of just provide a little bit of background to help, put people's minds at ease and to provide a little bit of perspective around how AI is helping health and safety professionals. So some basic terms, just want you to hopefully understand around AI. You can see them here. Artificial intelligence being the broad umbrella term for all of this new technology that's coming out. Machine learning is sort of a subset of AI that I think is probably what a lot of people think of when they think about AI, actually, is this use of algorithms and other statistical models in order to be able to take a set of data and then identify those trends and make predictions or decisions or recommendations based on those trends or assessment of the data. Natural language processing is another one. Think about predictive text. That's a great example of natural language processing. And then generative AI. So these are, your AI models that you think of these days, things like ChatGPT, Gemini, Microsoft Copilot. These are just sort of models that people can use to analyze and assess data with far greater computing power than, you can ever have independently. There are some, justifiable concerns about AI. Um, you know, a lot of things can go wrong if we're not feeding in good data and asking the right questions of AI. If you look at the images here, we're seeing, this is actually what happened when I told AI to generate four images based on, some key terms, things like context, language, assumptions, and it's misspelling things, it's using the wrong words. It just doesn't have any way to make great sense of it. And this is just an example of if we're not asking it the right questions and not feeding it enough good data, that it just kind of spits out a bunch of garbage. And that's one of the big risks with these open AI models, these generative AI, chat GPT types, is you never have a lot of confidence in what you're going to get back because it is sort of pulling from everything on the internet, and not a really great way of interpreting it. But there are some obvious benefits to AI as well. I mean, it can compute and provide analysis much faster than humans can do alone, even with powerful software like Power BI or Excel sheets. It goes way beyond that in our ability to analyze and interpret data. And because of that, it helps us to make better decisions faster. It can, assimilate all this data, help us to make sense of it much, much quicker, and then ultimately help us to reduce errors. Speed is the big benefit here. And so some of the other things that especially EHS managers, but I think most people are apprehensive about are, some of these perceptions that AI is going to replace us. Um, it's not, especially for EHS managers, and health and safety professionals, there's always going to be the human decision making and human judgment that is, ultimately making the call that's always going to be needed in order to implement these life and death decisions around workplace health and safety. So it's important to remember that AI is not a replacement. It is a tool to help us do our jobs better and and provide new insights and new perspectives on things that we might not always be able to see ourselves. But again, it comes back to having a good AI model, uh, and in order to avoid those hallucinations and just sort of this random errors that come out of AI a lot of times. It all depends upon the quality of the data that you're putting into the AI model and how you train it, how you train it to interpret that data. And so, making sure that we've got high quality, well labeled data, a large quantity of data, and that the model is trained and built and designed using uh, area specific expertise. And in this case, with EHS professionals, health and safety professionals, if you're using a model that is trained by experts in that field, it looks at that data and it looks at it in a way that a health and safety professional would, rather than just this sort of random assessment of what it's looking at. Okay, so how does this work with PSIFs specifically? It can help us to overcome some of the challenges that come from incident near miss investigations, because that, as I mentioned earlier, is really a critical component of being able to draw actionable insights about reducing SIF risks and about where to focus our efforts in terms of controlling those risks. Many companies are faced with resource constraints about when it comes to investigating incidents and near misses. Folks may have a lack of expertise when it comes to being able to spot hazards and identify, underlying root causes. Um, and then also maybe the lack of ability to select the most effective corrective and preventive actions and controls. Despite our best expertise, if we're kind of looking at injury and illness or prevention within, on a case by case basis, we might make one decision one day and make a completely different decision the next day based on the circumstances. So, as we'll see in the next couple slides, AI can help us to supplement, some of this lack of bandwidth, some of this lack of skill or knowledge, and also help improve consistency of things like hazard recognition and root cause analysis and control selection across incidents and over time, so that we're taking a more standardized approach to injury and illness prevention instead of just kind of viewing things as isolated incidents and viewing them with a more holistic lens. So let's say we're looking at an injury or an injury or incident near miss description, whatever you may have. Um, we need to, one of the biggest things that we document when we perform an incident investigation is the incident description. And that's really the basis for how we are then going to be able to identify the associated hazards and then the root causes of those hazards, and then selecting the appropriate controls for those root causes. It's sort of this sort of chain reaction effect, where we need to have good information in our incident description in order to be able to do all these other things down the line, to do them well, to do them accurately. So if we start with a poor incident description, like worker was sprayed with a chemical, we're not going to be able to tell very much about why that incident occurred, what were the underlying root causes, what we need to do in order to prevent it in the future. So we need to beef up our incident description. And what AI can help us to do is use natural language processing in order to prompt a user, somebody that's entering this information into a system, to be more specific, to be more thorough and detailed in their incident description, provide, specific facts. What the natural language processing can do, and this is something that Velocity EH&S incident management software does, is to prompt a worker to supplement those details in the incident description until it satisfies this sort of scoring system that's built into the software in the background. Um, you know, it'll prompt them to provide more details until it gets to a sufficient level of quality and detail. And then from there, the system can tell if it was a PSIF incident, if there were SIF risks associated. So, we see things like there was a presence of a hazardous chemical at 150 degrees C. Um, Worker was wearing PPE. These are the potential health and physical effects of exposure to that chemical. And then we can say, yes, it was a PSIF incident, or no, it wasn't. So we accept or reject it as a PSIF incident. Let's say it is accepted as a PSIF incident. Then we need to look at those hazards. Well, because we have such a good incident description, we can pull out individual hazards that were present uh, in that incident or during that incident. So knowing those hazards, the AI can actually pull out those individual hazards, um, and then uh, based on historical data as well as sort of the built-in expertise of the model that I was mentioning before, training that model using EHS, health and safety expertise, it can then say whether or not those hazards were, or make an assessment of the severity and probability of those hazards. More than that, what it can do is look at those hazards, and based on that same historical information or historical incident data and that built-in expertise, it can determine or make recommendations as to what the potential root causes of those individual hazards were. So it's not just us saying, all right, so there was an exposure to a harmful substance, um, and coming up with on the spot or without having to do a complex root cause analysis methodology. um, it can, recommend root causes based on the known information. Once we know those root causes, or we have, the system has provided the recommendations of those root causes, we can accept or reject those root cause recommendations. And then once we know them, the system can then also recommend corrective actions and controls based on, if that root cause hazard and root cause was present in a previous incident, and then we implemented a specific control for that, and then it knows that that cause that control was effective at reducing the SIF risk. It then knows that in the future it should recommend the the same corrective actions. So once we know the root causes, it assesses known control performance and previous past control recommendations to provide a new set of controls for the root causes that it has identified for the current incident that we're looking at. And then you can, of course, accept or reject those corrective actions and controls. And then from there, you can assign them out and monitor their completion and closure, and carry them through to completion. So that's kind of an example of how velocity AI, and we have a built-in AI assistant called Velo, and how that works with our incident management software in order to be able to kind of uh, guide you through the incident investigation process and reduce a lot of the time and effort that's required to perform a really high quality incident investigation, do the root cause analysis, develop the corrective action plan, and then carry that through to completion. And Velocity AI and Velo are applied to other aspects of our software as well, including ergonomics, job safety analysis, and contractor safety software. So if you would like to learn more about how Velocity EHS incorporates our Velocity AI and Velo in order to, supplement and refine um, the expertise and the effort of health and safety professionals, and to improve the ability to assess the data that you're getting out of your health and safety management program, and help improve health and safety outcomes. Check out our website. You can scan this QR code, go to ehs.com and learn more. With that, I'll hand it back over to Samantha. We've got a few more minutes in case there's any Q&A. And I just want to thank everybody for joining us today. I hope you all learned a little bit about PSIFs, and if you're not already tracking them in your workplace, you have an idea of how to go about doing that. And if you already are tracking them, hopefully we've helped provide you with some guidance to improve that process, and including, making you aware of some of the technologies that are out there to help streamline that effort. Thank you, everyone.
Perfect. Yeah, as Greg mentioned, now is time for Q&As. If you have any questions for Greg, get them in the chat. We had a question come in. It often comes in on these type of webinars, and they said, is it good to set limits on the numbers of PSIFs reported? I know of an organization which set limits on PSIFs because of a high number that was being reported.
I mean, you don't want to set any arbitrary limit on how many PSIF incidents or PSIF qualifying incidents you may be seeing in your workplace. And I guess that number would be influenced by how you're classifying them. It's tough because if you are looking at past incident data, or even if you're looking at incident data in the here and now, and you look at these hazards. Okay, so there were extreme hazards or high hazards present when this incident occurred. Um, the incident was not severe. It didn't even, it might have just been a near miss. Nothing happened. But as a result, we've identified the presence of these extreme or high hazards. Um, yeah, that's a judgment call that you'll need to make is, you know, what level of severity of hazards, or what level of hazard would you classify or categorize as being or presenting a SIF risk? Um, I don't have any, hard answer for you on that right now. But, I would say doing what like our software does is look at historical incident data, and you look at incidents where that same hazard was present, and say, well, were there any actual severe injuries or fatalities that were caused by that same hazard? And then, making an assessment of, well, this severe injury or this hazard has contributed to a SIF, on a few occasions, two occasions in the past. Would that qualify as a SIF risk here? I mean, if it had contributed to a SIF at all in the past, I would say yes. But I can understand your concern, because if you're starting to categorize every injury or every incident, even near misses, as a SIF or having a SIF risk, then you're going to see that number just explode. Um, it's a tough call to make. But again, the best advice I can give you is to just look at that past incident report data or near miss data, not near miss data, but incident report data, and say, were there actually any injuries or SIFs caused by this hazard? And I think if the answer is yes, you would want to categorize that as a SIF.
Well, thank you, Greg. We have time for one more question before we wrap it up. If anybody has any questions, still write them in the chat and get in touch. We'll send all of the questions over to Greg at the end of this. So a great question to wrap it up with is, can this software be used for languages other than English?
Yes. Our software is available in, I can't remember the number off the top of my head. I believe it's over 30 languages that the software is translated into. Um, and if you have questions about specific availability of specific languages, reach out to us. You can ask call in, ask questions. You can email us. You can email me, and I can track that number down for you. Um, but yes, the software is translated with just a click into something like close to 30 languages. So yeah.
Fantastic. Well, that's always great to hear. Accessibility is so important, especially to our audience. So, Greg, I want to give you a huge shout out for being here today and giving us so much valuable information. This is a huge topic, and I'm sure we could spend a lot more time on it. So, make sure that you stick around to find out what other conversations we are going to have in the future on PSIFs and what we can do about them with the technology that's available to us. A huge shout out to Velocity EH&S for allowing you to be here. And of course, I want to thank our audience and every one of our dedicated safety professionals because without them, none of this would be possible. So thanks again. Take care and stay safe. Bye, everyone.